Okay, welcome to a special recorded live episode of the Engineers HVAC Podcast, where our mission is to empower and educate the HVAC community. This podcast is brought to you by Insight Partners and Hobbs and Associates, two commercial HVAC rep firms. I am Tony Mormino, your host, and I'm with Insight Partners. And today we're going to be discussing HVAC control valves, including the basics and the latest technology. And to do that, I have a special guest today, Tim Lilly with Lilly Engineering and co-founder of the 11-minute construction podcast, not the 10-minute construction podcast, not the 11-minute construction podcast, which I've been fortunate to be a guest on. So Tim, how you doing today? What's going on?
Pretty good, Tony. Thanks for having me. Excited to be here. And yeah, 11-minute podcast, because that's the only domain that Ben and I could buy. So all the 10 and 15 and 20 and hour-long podcasts, those were taken. So it's either 11-minute or like 12 minutes and 18 seconds, and we kept it simple. So
isn't that funny? Minutes. It's like people think there's some big creative thing behind it. No, it's just the domain we could get, but
right.
You
and
guys
don't
are
let our
doing
secret
awesome.
Get out, but we're lazy and we only record for 11 minutes, and now we don't have to do any editing, none of the fancy stuff that you do. So
I love it. I'm pretty lame on the editing too. That's why I like to do these live, because you get what you get and you just post them afterwards. So it's really nice. So anyway, if you're tuning in and you want to learn a little bit about control valves, we're going to talk about, I've been in the industry for 25 years. I'm embarrassed as to how little I know about valves. Like, I know there's a lot of different types. I know it's important. In the beginning, I'm like, okay, it's a 2-inch pipe, get a 2-inch valve, put it in there, but there's a lot more to it than that. So Tim, why don't you tell the listeners a little bit about your background, what you're involved in, and then we'll get into like different types of valves and the new technologies and stuff like that. You mind doing that real quick?
Sweet. I'm the luckiest person in the world, because I get to work for a family company and I get to see my dad every day. And so my grandfather started Lilly Engineering in the 60s after the birth of his 10th kid. And the guy he was selling for cut his commissions. And so he thought, wow, I got to go out on my own. So he went out on his own, 10 kids, started selling. And from there, my dad and uncle came into the business and they started moving their own products and designing. And now here I am and trying to sell the valves. And so
it looks like you're working in a shop. Was that your dad behind you there?
That was my uncle. So
okay.
He disregarded all the signs on the wall too to barge right in. So
he said, forget about this podcast. We're working here. We're working for a living. So that's great.
Right.
I love it. It. Well, good. There he is. Yep. That's how we roll around here, baby.
Sure
that's
is.
Awesome.
Paid advertising. That's what he thinks. So
I love it. 100%. Good. Well, that's great. And thanks for coming on the podcast today. So why don't we start with, like, if you're new or if you're like me and been around a while and know little about valve, like talk about valves 101. Let's talk about, I guess, chill water and hot water valves. Would you focus on that maybe, or what do you think?
Perfect. So we come from an industrial world. So we started selling a washdown nozzle, this little guy, to the breweries. And they came to us and said, hey, we need better control valves. The valves we have in there now are too expensive. They're too big, and we can't control. And so you go from, say, a brewery to a steel mill to a refinery. The valves are very important, because the guy who's buying that valve is also the same guy who's getting a call at 1 a.m. saying, hey, this valve is working, this valve isn't working, production is down. And so that's the world where I grew up. I cut my teeth. I learned there. And then you come to the HVAC world, and the valves are kind of an afterthought. It's a low ticket item.
Interesting.
It doesn't really make or break. It's not as sexy as a chiller. It's not as cool as a water tower. It's just, it's an afterthought. And so you have all these fantastic engineers who design these P&ID loops and do all the fancy programming. And then the equipment is the slave of the program. It executes exactly what you want. And so what I always tell people is, it's the exact same concept as trying to take a math test. You can either use a calculator or you don't use a calculator. Obviously, it's much easier if you use a calculator, but you can get away with not using the proper equipment. And so from an HVAC standpoint, we've kind of seen that people just say, I don't really care. Throw whatever in there. Go grab the cheapest one off the shelf. And from the industrial world, it just doesn't make sense that that's how an entire industry can operate. And so to answer your question, there are really kind of three main types of valves when you get into these larger, let's say, control applications.
Mm-hmm.
So you have what's called a butterfly valve, a characterized ball valve, and a globe valve.
Okay.
And when you design a system and you go get a control valve, let's say the spec just calls for a control valve, it's that little icon with the hat on the top.
Mm-hmm.
What you want is what's called equal percent flow characteristics. And so that looks like this. Let me pull up a.
So give me just a rundown. Globe, ball valve, and what was the other one?
So you can either have a globe valve, a characterized ball valve, or a butterfly valve.
Okay, we're gonna have to go through some of that. Great. Okay.
And so when you pay for a control valve, you're paying for what's called equal percent flow characteristics, which hopefully you can see it right there.
I can see it.
Nice
Yep.
parabolic looking line. And basically what that means is for every 5% change in your disk, you get a 5% change in your flow.
Right. So you don't want to crack it open 10% and get 40% of flow, similar to kind of an air valve, like a VAV box.
Right.
Yeah. Okay. Gotcha.
And so it makes your modeling very predictable.
Mm-hmm.
But the problem is, if you want those kind of flow characteristics, you have to go with a globe valve or a characterized ball valve, which are A, very expensive, and B, take up a lot of space.
So you're saying characterized ball valve. I've never heard that before. What is that? What is that? I know what a ball valve is, but what does it mean to be a characterized ball valve?
So if you think of your ball valve and you have your normal opening like this and it moves like this, your characterized ball valve's opening is going to look more like this. And so when you move, it's slitted and it controls how much water can get through that passageway.
So it keeps it even.
Yes.
In other words, 10% open equals 10% flow, 15% open. Okay, gotcha.
Yes. It moves along that flow curve.
And those are more expensive than a butterfly valve, which is not very precise. Is that correct? Is a butterfly valve the cheapest option you get typically?
A butterfly valve is the cheapest option, and it's also the smallest and the most lightweight. So I have a butterfly valve right here for you, Tony.
Oh, perfect.
This is
I love it. I love that you brought props. This is awesome. This is so cool. Yeah.
So this is your simple butterfly valve with your disc. And what you're trying to do is control the area of your seat, which is a circle. So do you know what the area of a circle is? Just
let's see. Pi r squared comes to mind. That's not correct though.
Nope, that is exactly correct.
Okay, gotcha.
And so when you're trying to control water through the area of this circle, every time your disc moves, you get an exponential change in your flow. And so let's say I'm at 65% open and I jump to 70% open. That's an exponential change in my flow. And I have no chance of controlling along that line, along that curve.
Gotcha. Unless you've got some very expensive water flow monitors in there, which are expensive.
Right. And then you have to figure out a way to program it. And it's a hassle. But most HVAC folks have to put it in because a 6-inch butterfly valve weighs 22 pounds, whereas a 6-inch characterized ball valve weighs 93.
Wow. Okay.
And let's say you're putting in a system in New York where you got guys like Ken Griffin at Citadel paying $3,000 per square foot. That valve takes up, what's the face to face? That valve takes up 9 inches, a characterized ball valve, which is, what is that, about $1,000 of space you're taking up just due to an
I never thought of that
inefficient,
aspect.
outdated technology. And your number one limiting factor is space. Right. That's why you have to put a butterfly valve in. You don't have the space to put something different.
You're talking specifically about jobs like in New York City where the rent is real high, or just in jobs in general, or I guess that would just depend, right?
Really just in general, because I mean, you're stuck inside 4 walls for the most part. It's not like you can blow out a wall so you can make your HVAC equipment fit.
Architects, they don't want to give you more room, do they?
Ever. They want it for the stuff that makes them money, like the coffee bar downstairs or the
that makes
juice
sense,
machine.
Right?
So
I never thought the different valve types take up more space. There you go. 25 years, I'm learning something new every time we do a episode like this. So the ball valves are more expensive. They're heavier. Well, they're heavier and they take up more room, which I'm assuming makes them more expensive. In my experience, something that's heavier and bigger is more expensive than something that,
Right.
smaller and lighter.
So if you think about it from a logical standpoint, you have 93 pounds of material versus 22 pounds of material. And so just based on a cost of material standpoint, it's a high premium.
Now, how many jobs, percentage wise, like I've been working with engineers for a long time, but I don't handle the valves, so I don't know even what goes on. What percentage of jobs are butterfly valves versus ball valves? Is there a 10%, 20%, half are ball valves, half are butterfly valves, or what's been your experience?
So it kind of depends on the size, Tony. When you have some of the smaller ones, like a 1 inch and below pipe, 1.5 inches and below, you see a lot of those characterized ball valves or even a globe valve. But when you get up to an 8-inch valve, you have no choice. You have to put a butterfly valve in.
Gotcha.
And so that's the exact reason that a major brewery in Milwaukee approached us, and I can't say which one, but if you can guess a brewery in Milwaukee, you got a pretty good guess at it.
Right.
And that's how we came up with the Z-Disc control valve, to solve that problem, to solve that need in the marketplace.
Gotcha. Well, we'll have to go through that in a minute. That for sure. I want to see that. So, but you're saying like in the industrial world, it's way more critical. The valve is treated like we would maybe treat a chiller. In HVAC, it's kind of an afterthought, but is equally as important, right? If your valve's not controlling right, if it's not the right type of valve and you don't get the right flow into the coil, it doesn't matter what kind of chiller you have.
Exactly. Right? And we've come a long way with the chiller technology, and they can handle some variance, but in the HVAC world, one side of the building might be facing the sun, the other side might be in the shade. So you have different loads. You might design a building in Chicago where sometimes it's 10 degrees, sometimes it's 110 degrees. And so you can control that variability with the valve. And it's very simple. It's very easy. You just have to pick the right equipment.
Gotcha. Okay, that makes sense. Now, talk a little bit about valve sizing. So typically let's do this. Can you hold that ball valve up and talk about the parts of a valve?
So I do not have a characterized ball valve with me. I'm strong,
I'm sorry,
Tony,
the
but
butterfly
I'm not
valve.
Strong.
Do it with the butterfly valve.
Yeah, I'll do it with our Z-Disc.
Perfect. Okay.
So this is a standard lugged style valve, which this is a lug. You can get it in a wafer, but that's kind of a European thing.
So the lugs would be where the flanges of the pipe would come to, and you'd put a bolt through there.
Yes.
But those are called lugs in the valve world. Got it.
Yes. And then this is your resilient seated liner.
Okay.
And so in your industry, they're all EPDM, which is just a rubber. And it basically makes it a soft seat, an O-ring seat. And then you have your disc, which in a standard butterfly valve, it just goes on off. But with ours, we can modulate. And then, move the mic. Oh no.
You're good. We still got you.
And then
this is no joke doing a live podcast with props, man. You gotta be on your game, right?
Right. Especially when you use the props to block half your face. That's what makes it half the fun.
You can tell if you're watching, we don't rehearse these, man. We just hit the button and go. So it's great.
Right. And then this is an electric actuator. And so it's very simple. You just run a wire or two to this, and then you give it a signal on a 0 to 10 scale, and then it'll move your disc and it'll modulate your flow. It'll go open, it'll go closed, and you can sit in your control room and set your program, send your wiring. You can run an entire steel mill with 2 wires, which is incredible. Right. Whoever figured that out is incredible. And you can do the same thing in the HVAC world. And they do it in the HVAC world.
So every valve or control valve has a actuator on it or some kind of way to turn the valve or control it, right? Call it an actuator typically. Looks like it's got a built-in feature. Can you hold the other valve, the Z-damper valve you had? Hold that up for a second.
Okay.
Just for the basics of valving, like the pipe diameter that connects to, is the pipe diameter represented by the black seal or by the inside diameter of the EDMP gasket? Am I making sense with that question?
Yep. So this is a 4-inch valve.
Okay.
And so this is a 4-inch
Opening.
It's actually like 3.98 or something like that. And then
Got it.
the gasket seals against the pipe. So it's slightly less than the number, but it's the number for all intents and
Understood.
purposes.
So the open area of the valve equals the pipe open area typically. I'm just like general valve sizing 101, trying to get my head around that.
Yes. So
Got it.
valve sizing, you do it based on what's called CV,
I was hoping you'd bring up CV.
and it's a coefficient. And so
Okay.
what it does is it takes into account your pressure, your flow, your temperature, and your liquid. So it's basically just a way to put everything on the exact same playing field.
Mhm.
That way you can size for every single application, and it's a standardized unit is what it is.
So the CV, the valve has a CV assigned to it, correct?
Correct.
And you pick that CV based on the pressure drop and the flow, the pressure drop through the coil and the flow. Am I saying that correctly?
Yes. So to
Okay.
calculate your CV, you have an inlet pressure, an
Mhm.
outlet pressure, your flow, and then temperature. And in most cases, it's going to be water. But if you get into glycol, it's a little bit different because you have the density of the fluid. And
Crazy
then
glycol, right?
every valve has a published CV. So we have published flow curves. You can look at our chart. The CV of our 6 inches, 720 all the way down to 8. And then you compare our CV and our curve to what you
Mhm.
need for your process to run smoothly. And then you plot it on the graph. And then you say, I need a 6-inch valve because the CV falls at 50% of our rated.
Now, in the 6-inch valve category, are there different CV options? Like I need to order a CV with A or a CV with B, or is it just the full range?
So it's the full range.
Okay,
And
gotcha.
what happens is a standard butterfly valve, when you have a control valve, what you're trying to do is eat some of that energy. So you have too much energy going through your pipe. You need to knock it down.
Mhm.
And so how you knock it down is important. And if you use a characterized ball where you have that slit, your CVs are a little bit lower, and you might have to go down a size, you might have to go up a size because they control within a narrow range. If you go to a globe valve, your
Mhm.
opening's a little bit smaller. So a lot of times if you have a 6-inch pipe, you might have to bump up to say an 8-inch or a 10-inch valve, and that reduces some of your cavitation and concerns going through the pipe. And
Mhm.
so it's really an art to size a control valve.
Yeah, you got to know what you're doing. And if you size it wrong, what happens? What are the challenges? What
So
kind of
if you
problems do you run? What kind of problems do you run into? What's the most common error you see, and then what are the results of that error when sizing valves?
so when you can be too low on the curve, and so now you're
Mhm.
not getting enough flow. You could be too high on the curve, and so now you're getting way too much flow. You
Mhm.
could have what's called cavitation, where it's going through the pipe and you're taking a very big pressure drop, and now you have
Mhm.
these little implosions that are just wreaking havoc. And you see that a lot of times when you starve a pump, but it can also happen with a control valve. And
Mhm.
those are really the main issues. Or you can just see it not operating on that curve, and now you've come off your PID loop, you lose your set point. Let's say you're making chocolate truffles and you need the inside to be the perfect temperature going into this truffle so it doesn't crack the exterior or it doesn't melt the exterior. You have to
Mhm.
be right on that set point, so you have to operate on that curve. So if your input changes or your output changes, you need a valve that can stay on that curve.
Nice. First truffle reference, I think, in 100 episodes on the podcast. So you're breaking new ground here.
Sweet. That's one of our proudest moments. So
There you go. There you go. So we talked about ball valves, globe valves versus butterfly valves. You look like that looks like a hybrid, what you got there. Tell us about what you guys have come up with as a solution, then we'll talk about the benefits of that.
So we designed what's called the Z-disc control valve.
Z-disc control valve. Okay.
And the impetus behind the design is, can we teach a butterfly valve how to control? So you have the engineers at the brewery in St. Louis, at the brewery in Milwaukee, excuse me, saying, hey, we need these valves to modulate. We need them to hit their set point. We need them to
Mhm.
stay right there. Can you do it? And so we first had to understand why you can't modulate with the butterfly valve in standard industrial applications. And so it turns out that if we re-engineer the disc, so I'll do a little side by side. So this is our disc. You can see we have recesses. We changed the geometry versus your standard butterfly valve disc, which is just a flat disc.
It's just a plate.
It's just a plate. And so by changing the geometry of that disc, we can now teach a butterfly valve to operate along your equal percent flow curve, which gives you greater control over your set point. Let's say you're opening a chiller nice and slow and smooth and you want it to be on that curve. It makes it a lot easier. Let's say you're feeding a coil and you want it to have a certain pressure drop coming into it. It really does wonders, and it operates like your expensive control valves, but it's that simple small platform.
Z-Disc control valve. And we'll put that, if you're watching this on the podcast or on the YouTube channel later, we'll put the link to that in the show notes so people can come and check that out. So that looks like a pretty cool invention. How long have you been selling that in the HVAC world?
So I went into a steel mill and I came out and I was covered in soot. I showered 3 times for 3 straight days and I was still covered. And I got out there and I looked at my dad and I said, Dad, I'm going after the HVAC world. And so that was about 8 months ago. And so trying to start a tour of just educating people that, hey, there's an option out there. We have a solution. We've designed something. We've taken an industrial solution, brought it to the HVAC world. And Ben and I talk about how the HVAC world can sometimes be slow to adapt modern and new technology. And we're trying to bring a solution. In the industrial world, they're all going towards rotary control valves. And so we like to think we're at the forefront of it. We're poised to do it. So, and you need a small company like Lilly Engineering to pioneer this. Because let's say you go get a 24-inch globe valve from Fisher, who's the big player out there. They're going to charge you probably $150,000, $200,000 for that valve. Whereas you can get a 24-inch control valve from us, and it'll probably be 50 to 60, and then you put an actuator on there. So Fisher's not giving up that pricing power, that control. So it takes someone who's
you're a disruptor,
right? The chaser.
You're like the Steve Jobs of the control valve world. I love it.
Right.
I love it. Good. Now let's talk about. I had a couple questions on here about. One of them was like integrating valves into existing HVAC systems. So can you talk a little bit about the challenges of you're going to upgrade an HVAC system, you want to change out the controls and the valves. What are some of the challenges people run into with that? And how does you could talk also about how your solution is better over in some situations.
So that's one of the situations where your number one limiting factor is probably space.
So because you got what's there. You're stuck with what's there.
Right. And so let's say I have a butterfly valve and I want to put in a control valve. I only have this much pipe in front of me. I can't find another 6 inches to put in that valve. And so with us, we have a minimal face-to-face. We have the narrowest face-to-face you can have for a valve that size. And what that allows you to do for retrofits, if you have an engineer who says, let's put a control valve in there, let's put a modulating valve, you could put the Z-Disc, because it's so narrow, it's so tight, you just drop it in, plug and play, because your hands are really at the mercy of what's in there now, what the engineer did before, how he set the system. It might be exactly how you set the system. It might be nothing like you would set the system. And so that's really where it becomes an art. And you can kind of see the beauty of the minds of the people designing these systems. And when you walk into a well-designed one, it's awesome. It's so cool to see.
Nice. So I like that. You're another tool. We call these tools in the tool belt, tools in the engineering tool belt, right? When you go in, there's not enough space. So look for that as an opportunity. So troubleshooting valve performance. How do people troubleshoot to see if the valve's causing it? You have an issue on a job, you're not getting enough cooling or whatever the issue is. How do they troubleshoot valve performance typically?
So a lot of times you can go right to the valve. You take a little handheld device, which I don't have, it's downstairs, and you just plug directly into your positioner or actuator, and then you can stroke the valve and see how it's working. Really, the number one wear point on a butterfly valve is this gasket. And so it's a rubber liner, and it can wear down over time. It's not human, it's a rubber liner. And so that's really your only wear part in these situations. And
Gotcha.
I know some of the people listening to this podcast probably install a lot of butterfly valves. The number one reason a butterfly valve fails, Tony, is that when you go to install it, you install it in the closed position, and then you put it between your two flanges, you clamp down on it, and the first time you come out of the seat, you rip your liner, and you started leaking before you even run water through it. So if you're listening and you can install your butterfly valve at about 3% open, just enough to be outside of that liner, you're going to extend the life of your butterfly valve tremendously.
Because when you flange it, when you compress it, it expands the rubber and it pushes against the valve if the valve's shut. Is that what's happening there?
Yes. And then when it comes open, it just rips some of that rubber away, and now you have a bad seat.
Now, for the life of the valve, it's not sealing properly or seating properly.
Right. And that's everyone's butterfly valve. That's with our valve. That's with any resilient seated butterfly valve out there.
Gotcha. That's good advice. Good information. So let's see here. Another question. Valve material selection. Is there different types of materials to valves, or what have you seen with that? I know there are. But can you talk through the different types of materials and when you would use what?
So you have a couple different materials. From a body standpoint, I brought all the stainless steel ones today because they're nice and shiny, and I was going
They look cool, yeah.
And so they look nice. Or you have cast iron. If you get closer to the water, to the oceans, then you can start playing with some of the fancy, fun alloys like super duplex and that kind of stuff that makes a valve very expensive very quickly. And so if it's inside, cast iron, pretty much the standard. If you're in a food processing plant, stainless steel, pretty much the standard. If you're outside, it's kind of the discretion of the engineer if you want to go stainless or cast iron, just based on the elements. And then from a liner standpoint, EPDM is the standard. So your gasket. And that's just a chemical makeup. But you can get it in like Viton. Let's say you have biogas running through your butterfly valve. Which if you have biogas running through your butterfly valve in an HVAC application, you're in some trouble.
That doesn't sound like a good day.
Does not sound like a good day.
We don't get into a lot of biogas control around here that I know of. So
right. Or you can have a Teflon seat. Some people like a Teflon seat. It's rated to a little bit higher of a temperature. And then there's a couple other specialty ones if needed, but those are really the three main ones.
Got it. That's good information. Okay. What are the best practices for maintaining chilled water and hot water valves? Is there a lot of maintenance involved in valves?
There's not. And most of the butterfly valves are what they call throwaway valves. So you're buying let's see, I quoted an 8-inch butterfly valve yesterday for $800. And so it's not worth your time to go maintain it and buy a repair kit and fix it. Because after that's all said and done, the amount of labor that went into it, you're better off just putting in a new valve.
Right.
And so from that standpoint, it's pretty simple. If you have an expensive control valve, it changes a little bit, but it's a very simple, it's a simple device, which is nice. It's easy. It's awesome.
Got it. Good stuff. Okay. So somebody asked about VFD. They said VDF pumps, but I think they meant VFD pumps. Not sure that has a lot to do with the valves, but we see VFD driven pumps all the time. So I'm a big fan of those from an energy standpoint. Yeah. Anything to add to that? Anything to comment on that, Tim?
I don't know anything about pumps. So
they're more efficient when you have a VFD on them. Let's say that we know that. So yeah, we're big fans of that.
My little brother sells pumps for high viscous fluids. And so that's that's about all I know. So if you need to pump yogurt, I know a little bit about pumps, but
call Tim's brother.
But if you want to do anything,
you got the family thing. You got to call your brother, call your uncle walking around in the background. You got like it all going on over there. It's nice.
Right.
Okay. So training, we're all about like trying to give back to the engineering and contracting HVAC community. You got any training tips where people could go if they're new or they want a refresher on Valves 101? Any YouTube channels? Or obviously the 11 11-minute construction podcast is a great place to go. Anything, talk about your show and then talk about anywhere else people could go get some education.
So the 11-minute podcast is pretty fun. And basically Ben Ledane and I, we're sitting around and talking to some of our buddies, and they're accountants. So they sit behind a desk all day, and I'm in sales. So I get to call and talk to interesting people like yourself. And I go on the weekends and I tell my buddies, like, yeah, I met this guy doing this. I met this guy doing that. And like, that's so cool. And I was like, well, everyone would find this interesting. And so the people I find interesting, I just say, hey, do you want to come on a podcast? It's 11 minutes. You get to explore one concept in depth, or two concepts kind of in depth. They come on, they talk about their life, their experience. And Jay-Z has a great quote that everyone has genius within them. You just have to find it. And most people don't have a platform. Right. If I'm a CPA, I'm just sitting behind a desk working on Excel all day long. But those people are brilliant. And so it's Ben and I's mission to give these people a platform, like, hey, I'm doing something cool here. Look at this. This is awesome.
Yeah.
And so for 11 minutes, you can come on. We get 6,000 people are like, yeah, this is pretty cool. And so we're just trying to find people who are out there working, trying to find their genius and give them a place to showcase it. And all my friends who are stuck behind a desk can now see what people are doing out there. I mean, life is awesome. And so you give these people a platform, and I don't know. I love it.
I think it's great. I think it's great. While we're on the topic of, educating, the HVAC community or the construction business, talk about your experience with that. Like, how long have you guys been doing the podcast now?
So I think we just had our 8th guest, and we've gone everywhere from a seasoned vet, 30 years trying to solve problems in the HVAC industry, to our most recent guest was 3 weeks in, doesn't even know the problems that all our guests are trying to solve.
Right.
Because he's just starting. And so it's interesting to hear the perspectives all along the chain of command. And you're like, this is so cool. And next week we have a guy coming on who's building LNG systems down in Louisiana, liquefied natural gas, and they're moving at the speed of light. And so it's awesome. We get to hear all these perspectives, all these people doing stuff, and it's awesome. It's a ton of fun.
That's so cool. Plus you get to build your brand and you get to raise awareness to your products. And, I was asked to be on the podcast, which I greatly appreciate. It was a ton of fun. Now you're on our podcast, and Ben was on a week or two ago. And it's just like, it's a really cool way to give back, I think. And when you guys originally talked about starting it, was there a lot of fear involved? Was there a lot of insecurity, or were you just like, yeah, let's go do it and just turn the camera on? Or how did that work for you guys?
Pretty much. Yeah. Let's just go do it. Turn the camera on. And Ben does all the back end work. He's freaking phenomenal. He understands more about technology than anyone I've ever met. So I do the easy part. I just show up, I ask 2 questions, and then I go have a cup of coffee. So, but
yeah, that's good.
It's been so rewarding. I mean, I can't say enough good things.
What advice would you give someone if there's an engineer watching this? And I know in our industry, like, we're very far behind, I think, in using the online tools. We started using them during COVID, and it's been a great tool for us to reach, not just to give back, which we truly enjoy doing, but, we are a business. We do have to sell. We do have to build our brand. So we do it for that reason as well, obviously. But what advice would you give to someone who's in an industry? Like, I see some mechanical engineers out there who have, starting to do a little bit more like this, but what advice would you give them if they want to use these tools to raise awareness to their audience, or promote their brand, or to give back to the community? What kind of advice would you give someone like that in an industry where they typically don't do that?
Right. So I pretty much have 2 things, and it's like every single teacher you ever had in high school and college, Tony, saying, if you have a question, someone else in the class probably has a question. So if you find something interesting, someone else probably finds the same thing interesting, but they might not have an opportunity to see it. So everyone's got their phone on them. You just take a picture, record over it, say, hey, this is cool, throw it out there, see if it sticks. And you have so many platforms out there. And then the other thing I would say is, if you come across something and you're like, oh, this is so cool. Like, if you read an article in a valve magazine, say, oh, this is so cool. Call the person who wrote the article, because they found it cool. They'll have a conversation about it. Like, if I see something that I find interesting on your podcast, I'll give you a call. If I find a guest on your podcast that I find interesting, just look him up, find his company, call the secretary, and say, hey, I'd love to talk to so-and-so. And you have a 10-minute conversation about it. And you get such a wealth of knowledge from picking up the phone. And ever since kind of 2020, people have they've kind of strayed away from picking up the phone and calling and having a conversation. And it's the greatest thing you do. Human communication it's so cool. I mean, whatever adjective you want to put on there. And so pick up the phone, call someone, have a conversation. And next thing you know, you're starting a podcast with the guy. Like I called him out of the blue, saw the phone number on LinkedIn, was bored, said, hey, what's up? 6 months later, we have a podcast. So my biggest thing would be pick up the phone, call someone, have a conversation, and enjoy it.
Good advice. Okay, that's a great ending point. That was awesome. Thank you, Tim. So how do people get a hold of you? Give us your website. And again, if you're watching this, I'll put it in the show notes afterwards. So what's your website?
LillyEngineering.com, and that's Lilly. Or there's a phone number on there. Just give us a call. We can set up a Zoom call, fly out to see you.
So that's right. The uncle's waiting in the back. We just saw him. He's waiting back there for your phone call. So give him.
Right. He probably went to go get donuts now that I distracted him. Hopefully he's coming back with donuts.
There you go.
We'll see.
Well, Tim, thank you so much. This was very educational. And thank you all for listening. You could check us out at our YouTube channel at HVAC-TV. You can type that into YouTube, or you can check out our podcast, the Engineers HVAC Podcast. There's a QR code in the upper left. So I'm going to put up some QR codes and a little timer here with a little music. And Tim, why don't you hang out with me in the waiting room? We'll talk in a minute. And thank you so much for joining us. We appreciate you.
Sweet. Thanks for having me.